Okay, so let's go. Well, guys, first of all, thank you for having me here. I'm really happy to be here and to do this in person. I haven't seen your faces yet, but I'm sure that I hope actually that you enjoyed the part 1 and part 2 of the series. And my name is Giuseppe. First of all, you did part 1 and part 2 with Simone, which is the head of developer relations. I work in his team at IoTeX. And yeah, today I guess we're gonna do the part 3 of 3, and we're sort of trying to put everything together and basically do a little demonstration of how like these applications that we've built over the course of the past couple of weeks is going to be working. So I wanted to start just by doing a quick recap on what we did, and maybe see if you guys have any questions or if something is unclear before we actually move ahead, right? So during the first part of the workshop, Simone went through an introduction to blockchain, and especially the limitations when working with the real world data. And in that regard, we also talked about the MAchineFi methodology that is developed by IoTeX. And also we looked at the Arduino firmware that we're going to be using for this workshop. And again, it's sort of like a simple proof of concept, can always be improved, but at least it's a starting point. When working with part 2, we looked at WebStream, which is the off-chain computational infrastructure that is developed by IoTeX, that sort of sits in between the IoT devices sending their data and the actual decentralized applications that are that can be built on the blockchain, right? And the main objective, or the main use of WebStream, is to generate proofs based on this real-world data that's coming from these devices, and to then be used in decentralized applications. So I just wanted to also give a quick review of the architecture of the applications that were of the application that we're building today, and just to, I mean, we went through this in part 2, but just to give a quick overview. So we're going to basically be using the Arduino Nano 33 IoT, which I have right here. We went through how to flash a firmware with secure boot, so that the Arduino would actually have a private and a public key pair that we can use to then sign the messages that we'll be sending. We are going to use the smart contracts. Actually, that's what we're going to look at in a few minutes. We're going to store the public key, or better, the ID of this device into the blockchain. And we're also going to use the smart contracts to then bind this device with my blockchain wallet, so that then I can use my wallet to then retrieve, or the rewards that I can accumulate by using this application. So at this point, then we will be sending data to WebStream. WebStream is going to be in charge of doing some verification, authorization, and also storing the data. And then WebStream is also in charge of responding to the requests that will come from the blockchain when we are doing some physical activity, and also when we want to then claim our rewards. Okay. Other than that, I think we are good to go. So today we're basically going to put everything together. As I said before, we're going to do just a quick review on how to use the MetaMask wallet with IoTeX in order to interact with the smart contracts that we have in our project. And we're going to be looking at Hardhat, which is a suite of tools that we can use to deploy smart contracts, run some tasks, and interact with the blockchain. So before we get going, I keep saying before we get going, eventually we'll get going, but I would like to point out that all the materials that we're looking at today is going to be in the developers portal. So I just wanted to basically show you. So let's say you go home, maybe you want to try this out a little bit. You are actually able to find this under Academy. You can see that we have the first 2 lectures that we went through with the video and the quick sort of overview. But at the same time, you also have a full workshop that's divided in 3 parts, part 1, 2, and 3, that you can actually go through and explains what we are doing today in just a little bit more detail. You can read through. It has the code examples, and it's also linked to the GitHub repository that we're going to be using today for our project. And now, without further ado, yes, Professor. Yes.
Does that provide a step-to-step guidance?
Yes. So I'm just going to repeat the question just in case it's hard to record to hear. So the professor is asking if the Walk to Earn workshop part 1, 2, and 3 is actually providing a step-by-step guide on how to do what we're doing today, and the answer is yes. And it's also linked to the code. There are some code examples, and there are some code snippets that are analyzed in a little bit more detail. And there is also like a little bit of a high-level overview of what the application is going, on the architecture of the application and how the application will behave. And actually has some good points about the limitations of the application itself. So definitely worth the read. So now we are going to then start looking at the contracts. So we have this project that I cloned from a GitHub repository that's called the Walk to Earn with Arduino. And then once you open the project, there is a lot of stuff going on, but we're going to be starting with the blockchain directory. So the blockchain directory is going to have a few things. We'll go through some of these files, and the folder where we actually want to focus our attention at the moment is the contracts folder. So this is where we actually write the 4 smart contracts that we're going to be using to basically dictate the logic of our application. So the 4 contracts that we have are the device registry, device binding, the token that we'll be using to reward, and the Walk to Earn, which does basically the bulk of the logic of our application. So the first 2 contracts, the device registry and device binding, as I mentioned earlier, are sort of service contracts, and they're used also by WebStream to know which device is actually registered and which wallet address is actually connected to what device. Then the step token is a simple token that we're going to use to reward our users for physical activity, and we went through it as well in part 2. And then Walk to Earn is, Walk to Earn is basically doing most of the job. As a matter of fact, Walk to Earn is handling the requests to obtain proofs of walking for a specific device. It is also keeping track of the response the WebStream has to these requests, and is also accumulating the proof of walking for an account as rewards with a certain reward mechanism, tokenomics, that we are going to be looking in just a few minutes. And again, we just pick something super, super simple, but then whoever makes this application can do what they want with it. So let's look at them. So first we said the device registry contract. So I'm just going to make this a little bit bigger. And it always happens. I guess you guys can see pretty well, right? So the main thing in the device registry contract is the following. It's this mapping that maps a device ID under the form of an address, which is 20 bytes, to a device data structure, which we are defining here. And so this device data structure is basically, it's super, super simple, but you can basically, you has 2 Boolean, one that shows if the device is registered or not, and one that shows if the device is active. And so these devices are then stored in the authorized devices mapping. So apart from everything else that we'll be seeing, this is sort of the core of this contract. We basically have a bunch of, we have this mapping that points from a device ID to an actual device. And I'm going to show you the functions that are going to basically work with this mapping. So you can see here we have a few modifiers, and we actually use modifiers in our functions. Modifier is basically like a macro in Solidity. That's a language that we use to write smart contracts. And it's basically code snippets that will be applied to our function. And we're going to look at one specific, which is called the only owner modifier, which is a very common one when writing smart contracts in Solidity. And the only owner modifier makes sure that only the owner, which is basically the person that deploys these contracts on the blockchain, is actually the address that is able to call this function. So basically here, what we're saying is, I'm deploying this application. I am the one that can register the devices, and then you guys can buy the devices and walk, do the physical activity, and then claim your rewards. And it also, we need to make sure that the device has not been already registered for obvious reasons, like we want just one device to be registered with one unique ID. So this is basically where we add the new device with the new ID into the authorized devices mapping, and then we emit an event that basically says that the device has been registered. And so events are really important here because, for example, we're going to see later on how web stream is actually monitoring these specific contracts and is also looking for a specific event to be emitted from the smart contract. And so when a specific event is emitted, then there will be some handler functions that will get triggered upon emission of this event. So the rest, you can go through it, but we're just going to do it quite quickly. We have a remove device that basically acts in parallel and opposite to register device, suspend device, activate device, and just this is an auxiliary function that we use to determine if the device has been authorized or not. And so again, these are the service contracts. They're quite simple, pretty straightforward. We won't spend too much time on it, but once you get a little bit juicier later on, when we look at the walk to earn contract, then we'll spend a little bit more time with it. So now it's device binding contract. So the device binding contract, basically the bulk of the contract is here. It's line 11 to 16. We have again another data structure that we're going to call device, that basically has an owner address and an index in the array of device IDs that we're going to be using to basically see how many devices are actually registered in our applications. And so we're going to now be using basically a combination of an array and a mapping to determine which person, which address owns what device, and also see how many devices are in total in our application. And so we basically look at the most important functions here, and we have the bind device function. That's basically what it's doing. It's adding a new device with a device ID and an owner address, and it emits an event. We also have, you can see we also have the only owner modifier that it gets applied to this function like we looked at earlier. Then we have the unbind device, basically that's the opposite thing. And then we have a bunch of auxiliary functions, like to get the device count, the device owner. And then we have a function here that's quite important, that basically allows us to see what devices are owned by by which wallet address. And without getting into too much details, basically, we're just going to loop through them by using the device IDs array. And as we loop through them and we actually recognize that the owner address is matching the address that we are looking for as the owner, then we'll basically just use this device as a found device. And then we just return them. We can then add the device, which is very important. So this is the auxiliary function that is called appear in the bind device. And basically what this function is doing is updating both the mapping on devices and is also pushing the new device ID into the devices IDs array, right? So those are the two structures that we use to basically play with this little database of devices. Other than that, we have the remove device that basically, I mean, it's pretty self-explanatory. We're not going to be using it for this example today, but again, you're free to just go through through these contracts in the developers portal, look at everything, look at the GitHub repository, and actually feel free to make any changes you want based on whatever improvements you like to see in the application. I'm just going to go quickly through the step token because we briefly mentioned it last time as well. So we are just creating a token. The ERC20, it's basically like a specification for certain standards that are used for in the blockchain for creating a token, right? And there is not much going on here because the Open Zeppelin library actually allows us to quickly define what the name of the token is, what the initials are, and just mint, basically create this amount of tokens here. And basically these tokens are assigned to the sender, which is the address that is actually creating this token, this function. And then later on, we'll see how this sender that creates this token is actually going to give all their tokens to the walk to earn contract, because the walk to earn contract is the one that's in charge of then distributing these tokens as rewards to the various users. And so that's coming in just a couple of minutes. We'll look at it. Now it gets a little bit more fun. So now we have the walk to earn contract. So the walk to earn contract is basically, as I said, is handling a few things, right? It's handling communication with WebStream and is also handling a little bit of the tokenomics for this application. So first of all, as I said earlier, we have a super simple reward tokenomics reward policy that basically is just a factor, like a multiplier, and then the number of steps get multiplied by this factor. And maybe you can have like a higher factor when you are new and you want to bootstrap your application so that people actually get higher rewards. As you become more popular, maybe you want to lower this rewards factor, and as your Okay. Simone, did I lose you at some point?
Yeah, last 30 seconds, 20 seconds.
Okay. Okay, I can roll back and then we'll do it. Okay, cool.
Yeah, the screen is not sharing.
Yeah, thank you. I'll share the screen.
Okay, perfect.
Good. Okay. Okay, so we're now going to, just pardon me, I'm just gonna repeat quickly because we missed like 30 seconds. I'm just gonna roll back. So we're now going to be looking at the walk to earn contract, and the walk to earn contract is basically in charge of the interaction with WebStream, as well as a little bit of as well as handling our tokenomics. And so I just wanted to point out, as I said earlier, that we have this rewards factor that we use. That's basically just a multiplier that gets multiplied to the number of steps that somebody is submitting for rewards. And as I was saying, you could have, for example, a higher rewards factor when you're trying to bootstrap your application and incentivize people to use it. And then maybe this rewards factor can decrease over time as your user base increases. And again, that's like a super simple example, but feel free to do whatever you like with it, or just make it as complex as you want. Now, the main thing to look at in this contract is the event that's this here. That's basically the request for an activity from a user that's going to request WebStream to do some verifications and make sure that the device is registered and that actually this activity has happened. And so this event gets emitted by the claim activity request function, which is one of the most important functions of this contract. So the claim activity request function, all it does, it makes sure that the person that is actually claiming this activity is in fact the owner of this device, If this person is the owner, then we move on and we basically send a pending request by creating a pending request object right here. And so the pending request object, we can look at it up here. It's basically this structure that has an ID. That's basically the device, the ID of the actual request, has the device owner, which is the address that's basically connected to my wallet. It has then a device ID, which is, in our case, is simply taken from the public key of our device, and it's just the first 20 bytes of our device, of this unique private public key pair that we actually booted in the firmware in part 1. And we'll look at it in a little bit more detail when we start deploying, and you'll see how it's all working together. After that, we basically have the from time to time. Basically, it's the time interval within which the user is making the claim for. And so we will see that obviously at the beginning, it will be from time 0 to time, whatever the time of the request is, and then the to time of the first request becomes the from time of the second request, etc., etc., etc. And then, so we create the pending request object, and then we emit the activity requested event that we looked at just a moment ago. And this is the event that WebStream is monitoring, and that's basically going to trigger the some handlers for some verification. And after that, WebStream is going to respond with the claim activity reply. Now, the important thing to know here is this. So WebStream needs to call this function here. And if you saw earlier, we have the only owner modifier that basically does the same thing that it did before in our function, which is this modifier makes sure that only the owner, only the deployer of this contract can actually call this claim activity reply function. So in our case, what we're doing is we're giving WebStream and the deployer of the contract the same private key. So you will see in the WebStream configuration where we can add a private key to WebStream, that private key is actually matching the private key that we are using in our wallet when we are deploying this contract. So in a way, these two entities trust each other because they have a ownership relationship towards one another. And so in a more complex scenario, obviously, we would have a decentralized network of WebStream nodes that do this. But in our simple example, for today's purposes, we just have one centralized node that basically does the verification and does the logic that we talked about earlier. And so we trust it that the data the WebStream is then sending back to the contract is actually correct. Otherwise, we would have to then send some proofs, etc., and then it gets a little bit more complex. So claim activity reply is going to be called by WebStream and is basically doing a few checks, making sure that we actually do have a pending request for this request ID. It's also going to have a few parameters that are going to be coming from WebStream. And if this claim activity, if the request has been successful, then WebStream is going to then update the user balance that associated with that specific device. And then it's going to update it by basically the number of steps that the user has walked times the rewards factor that we were looking at earlier, which in this case is 1. So basically, you walk for 40 steps, you get 40 tokens, And then, tokenomics is like a whole other thing. The value of the token can go up, can go down, etc., etc. That's sort of like besides what we're doing today. Again, it's going to update the to time, like I was saying earlier, and it's basically then sort of like checking off this pending request, so that now we know that that owner doesn't have, for that specific ID, doesn't have a pending request anymore. So that's what WebStream is doing. Now we have a couple of other functions that we're gonna be calling towards the end of this to basically see, to actually see these tokens in our wallet, right? So one is the claim rewards function. Actually, this is the function. It's the claim rewards function. And this is going to be used by us to basically claim our tokens, and it's going to then transfer them to the address that's associated with our wallet. And I'm going to show you how that is done. We basically just need to call some hard hat tasks in order to interact with the contracts from the terminal, which is not too complicated. Other than that, so we have all these auxiliary functions there, but the main thing is that all these tokens, once we deploy these contracts, all the tokens that were minted at the beginning in the step token contract by the deployer will then be sent to the walk to earn contract. And the walk to earn contract, which is what we're looking at now, is then in charge of distributing these tokens to the users. Okay, so I think this could be a good spot to pause because after that, we're basically gonna start getting ready to deploy, and we're going to be looking at MetaMask wallet. We're gonna be looking at the keys and the deployment scripts that we need to use from Hardhat. So if you guys have any questions, everything clear? Yes.
What is the current state of WebStream? Is it like decentralized?
I'm sorry, what?
What is the current state of WebStream? Like, is it decentralized or?
Yeah, so in our application, actually, I'll repeat the question for the people watching. So the gentleman is asking what the current state of WebStream is, asking if it's a decentralized network or it's a centralized network. So in our application here, we basically have a one node structure. And so in our application here is a centralized infrastructure. At the moment, in the general terms of IoTeX, we are deploying the version 1.0 alpha of WebStream within the next couple of weeks. And that is going to just be one node in the alpha version. And eventually, we're going to then implement the decentralized structure with its own consensus mechanism later on as the application gets more and more, the infrastructure gets more robust. Any other questions, guys? Anything that you wanted to know more about the contracts, curiosities? If not, we have so much going on until for the next 45 minutes, so we'll just move ahead. Cool. So now we're gonna get ready to deploy. So we looked at, let me see, actually, I'll open MetaMask, my MetaMask wallet here that we're going to be using for this example. And I'm just gonna open this in a big window so you guys can see it. Cool. So last time we were looking at how to basically interact with the blockchain and how to interact with smart contracts. And so one of the, let's say, most standard, most well-known ways of doing it is through a wallet such as MetaMask. And so what I did now, you can see that there are different networks that you can have in your own wallet depending on what network you want to connect to. And what I did, I connected my wallet to the IoTeX testnet. And there are some tutorials on how to do that in our documentation, but basically you need to find the right RPC endpoint and chain ID and things like that. So it's basically just a little configuration thing that you can do through MetaMask. And then you can request some IoTeX test tokens. And the best way to do so is in the developer portal. If you basically go to your profile and you actually do connect your wallet, then you can receive test tokens for practicing or let's say testing your application. And I mean, I'm pretty sure like you understand the difference between using a test token or the advantages versus like a regular mainnet token, right? Cool. I can just go through pretty quickly. I mean, it's no problem. So when we talked in the first lesson, we were looking at a blockchain as this big ledger that has all the transactions, right? So any sort of like read operation on this ledger is free. So you can just like open it, whatever you want. Everybody has access to it. You can read whatever you want, and it's all free. But when you want to start writing on it, when you want to maybe perform a transaction, do a transfer, or something that changes the state of this ledger, then you need to pay what it's normally called gas fees in the blockchain world, and it's basically money, right? So we don't want to implement our application and then find out that there is a bug, or find out that there is a major security issue or whatnot, and lose potentially a lot of actual money. So that's why there are test networks. So the test networks is a network that runs quite similar. It tries to mimic the real networks as much as possible. And the purpose of this is to basically use money that has no real world value to just deploy your application, make some transactions, make sure that everything is working properly. And then after that, you could then deploy your contracts to mainnet and actually use real money for it, and then you're actually on an actual network. So that's basically the difference. I'm gonna remove this, which is basically a token that I was using for practicing this today, and so we don't get confused when we actually do import a new token after we deploy the contracts. Cool. So I guess let's go ahead and do that. So we looked at MetaMask. I wanted to show you the private key matching. Maybe I will not show you the private key per se, but I wanted to show you here that in the .env file, we're actually using a private key that is also matching the private key that we will be using in the web stream configuration. And where we can see how the private key comes into play when working with the smart contracts is basically in this file. That's the hard.config file. So we're going to be looking at this file later on, because this file has all the tasks that we're going to be calling later when we claim our rewards. But for the time being, you can see here that basically we are creating a network called testnet. We just named this testnet, right? We just basically connected to this specific RPC endpoint, and we are going to be using this private key here that is imported from the .env file, that I just showed you a moment ago. And this private key is also matching WebStream. So going back to your question earlier, it's sort of like a centralized infrastructure right now, because they're basically deployed by the same entity. And okay, we're gonna look now at the hard.hat script. So this is basically the script that is telling hard.hat what to do when we actually want to deploy our contracts. And you can see that we don't have to go into too much detail here, but we're gonna have some logs just to basically show our account balance. We're going to then deploy the device binding contract. We show some logs. We're going to deploy the device registry contract, show some logs. We're going to do the same thing for step token. And then And then here we are going to deploy the walk to earn contract, and the walk to earn contract needs to know what the device binding address is that we just deployed, and what the step token address is that we just deployed. And so all this, as you notice, is working asynchronously, and that's usually the nature of blockchain. Let's see, the other thing that we do is basically, as I was mentioning earlier, we are then transferring all the tokens that the deployer of the step token contract basically minted to the walk to earn address, so that the walk to earn contract, so that the walk to earn contract is now in charge of doing this redistribution for our users. And then we have a few logs here that just remind us of what the next steps are. So when you guys try to do this at home, you know, it's pretty easy. It's pretty self-explanatory. It's going to show you step by step what the commands you can run in order for this to actually happen. So now we are going to then use this, which is the script that is telling Hardhat to basically run the script that we just looked at on the testnet network. And so what I'm going to do is I'm going to go here. I'm going to open the terminal, put my phone down. I'm going to cd into the blockchain directory, and then I'm going to paste this, and I'm going to run it. And now you can see that basically it's going to showing the first logs that we had in the contract, right? Account balance. So we're basically here right at the beginning. And then little by little, this contract is actually gonna start deploying everything. And then we are going to use the information from these logs to basically set up WebStream and to basically use these addresses when we actually run the tasks, right? So for example, now we just deployed the device binding contract. That's the address. Block number is really important as well. So block number is sort of like keeping track of the time in the blockchain, right? So the time in blockchain is measured by block number. And so we need that because when we basically start WebStream, we wanted to start monitoring the blockchain from a block that's like basically close to the contracts that were deployed, because blocks are incremented every X amount of time. And we don't want to obviously start at block 0 and then have to go another almost 2 million blocks before we actually start monitoring our smart contracts. So we're going to tell WebStream, okay, cool, you're going to basically monitor these contracts, look for these events, and start at this block height. Nice. So the deployment was successful. We have this amount of tokens we had before we transfer to the walk to earn contract. And what I'm going to do now is I'm going to copy and paste this because I'm going to need it later on. So I'm just going to copy this. And I opened an output.txt file here that where I just basically keep some logs. So these are pasted. I saved this, and you can see that I also kept track of the device ID that is basically the first 20 bytes of the public key of my board, which we're gonna use later because we need to register. We're gonna register this board in just a second. Okay, so we did this. Let's move on. Now we're going to look at the WebStream configuration. So as I was saying earlier, we need to tell WebStream what contracts to watch out for, how should the data from the devices should be received, and then what to do when the new data is received and or when a contract event is detected. And we're going to find all this configuration into the project.yaml file. So let's go ahead and look at it. I'm going to go here, and we're going to close blockchain for the time being. We go into source, we go into projects, we go into app, we go into project.yaml. Cool. All right. So as again, we need to first of all change the start height, right? So start height, we had it in the output, and let's start monitoring basically when the last contract was deployed. So here, we go here, and we paste this here, and now we looked at this with Simone last time, so I'm just gonna go through this pretty quickly. But basically, all we have to do is now give the new address for the device registry contract, and then give a new address for the walk to earn contract. And then we looked at basically how these handlers were actually working based on the events that were triggered. So the first thing, we need the device registry contract. So I go here, we looked at the device registry contract, and I just want to see the format. So device registry, okay, so without the 0x. So this. And device registry. Okay. And then the other thing that we need to do, so the ABI stays the same, the event stays the same, the handler stays the same. Now we look at the walk to earn contract, and that's the address that we need to look out for. So step token, walk to earn is here. Again, we don't need the 0x. And then we just paste it. Cool. Okay, just one more look, just making sure that these are correct. Yes, and yes. Okay. All right, and then basically here we also looked at with Simone last time how this topic was created and how the handler on MQTT data was created. So all we needed to do here is just basically tell WebStream what contracts to look out for, and the logic we already did last time. Cool. So we did that. The next thing that we're going to be doing now is doing some Docker magic. So now we're going to start Docker, and Docker is basically going to fire up a few services. So the database, the GraphQL API, and the MQTT server. Because if, for example, if we look at my Arduino right now, it's actually failing to connect to the MQTT broker because I haven't started the server up. So the device is here, is ready to go, and is connected to my phone's Wi-Fi, and that's all configured, but it doesn't have a server to send data to. So we're going to basically be doing that with Docker. So all I'm going to do is open a terminal. I'm going to open a new window. So we keep this just in case. Yeah, we're at root, and we need to do Docker compose up, and cool, and this is started. So at this point, I'm just gonna remove this. I mean, not remove it, but just like put it aside. Now we're gonna open a new terminal window because this needs to be running in the background, right? So we open a new terminal window here, and we move on. So now we're going to initialize the database, and we're going to run WebStream. And so these are two commands that we're basically gonna just provide in the command line. And so we are going to do, and obviously I have already installed all the dependencies that I needed. And so if you are starting this project from scratch, you would have to install a bunch of dependencies, and you can look at them in the JSON file. But then again, it's all explained in a little bit more detail if you look at it in the developers portal workshop. So at this point, I'm going to basically run initialize the database and run WebStream. So npm run build, which is also going to initialize the database. And then we just wait for a second, and then we run WebStream with another command. Cool. And this is npm run app. Okay, and now, for example, as you can see here, we are indexing the blockchain based on the block number that we gave WebStream a few minutes ago, right? So right now, WebStream is scanning the blockchain and nothing is happening. You know, as soon as I start moving the board, then WebStream is also monitoring the MQTT server. As soon as I start moving the board, a message is sent over, and then right now we will see how WebStream is going to actually take the data that receives from the board and actually disregard it because we have not registered the device yet. So I would say let's just try this out and show you, and then we will then register the device, bind it with our smart contract, and then get going. So let's do that. I'm gonna do, yes. Yeah, I probably talked for like 20 minutes without stopping. Yeah, you might have some questions.
You please summarize so far what you already did, and so that student has something in their mind.
Yeah.
So which part has already been done and which part hasn't?
Yes. So through the whole arc of the series, so first we did part 1, which was basically set the firmware for the board so that we, the logic basically of the IoT logic of the board. Then in part 2 with Simone, we configured WebStream and all the handlers that we looked at a moment ago in the WebStream configuration file. So basically what to do when data is sent.
I mean, for example, here you first basically use MetaMask, right? And then deploy the smart contract.
Yes.
And then you start the Docker. Right? So
yes. So, okay, I can go through it quickly. So what we did is basically, so we looked at the contract. Then we deployed them using MetaMask. And then we actually, one thing that I have to do is I need to import the token into my MetaMask so we can actually see it. After the contracts are there, I basically need to then configure WebStream. So I gave it what contracts to look for and what events was already determined earlier. So I just, exactly, that's in the project.yaml. So we can actually look at it. So we did this. After that, okay, WebStream now is taken care of. It knows what to do when the data is sent over. So at this point, what we're going to do is we basically took care of the whole structure. We're going to start sending data to WebStream. But there is one thing that we didn't do, which is register the actual device. Exactly. But we are going to use the blockchain to register the device. So we use the device registry contract that we looked at the beginning, and we're going to then bind a device with my MetaMask wallet, those two sort of service contract that we looked at earlier. So that's the main purpose of those contracts. And
that's the project of so for that one, it's basically an option, or it's something.
It's an off-chain. It's an off-chain layer. The thing is this, though. Obviously, when we release the new version of WebStream in a few weeks, it's going to be very different than what we have now. So this is basically as a demonstration, that I'm doing for you guys to just have an idea of how all these components come into play. So there will not necessarily be maybe the same project or YAML file that you configure in the same exact way. It will in fact be very different, and the architectural WebStream will be different. But this sort of at least gives an idea of what the overview of what the high level relationship between all these components is.
So there is a basic IoTeX mentioned.
Yes.
And then there is an option of Web3,
WebStream.
WebStream. And then this one, which we can configure and basically do what we want.
Exactly. Exactly.
And then this one will probably interact with the mentioned from time to time. record information.
Yes, and that's what we configured with those smart contracts. We configured the events that then get fired, and WebStream reads those events. So from the main chain, WebStream reads those events, does whatever we tell it to do with the handlers, sends the proof back to the contract, and then the contract, then we, for example, now we just reward the users with the tokens for walking.
Is this something like a layer 2?
Yes, exactly.
Okay.
So it's a layer 2 that sits in between the devices and then the blockchain on the other side, and so connects these two elements, these two entities. Cool. So let's just try this out basically. So now we've been indexing the blockchain for a while. I want to actually, before I forget, I want to go here and import the step token contract in MetaMask so we can see. So we could just go here and then we import token and we just put the token address, and you can see it already knows what the symbol and the decimals are because, yeah, pretty straightforward. And we just have now just 0 as TP. So I open this again, just making sure this is there, this is there, this is here. And now I'm just doing some intense physical activity. So I'm walking really hard right now, trying to make as many steps as possible. And you see here that we have some logs, right? So, and here, that's basically, it's telling us this device ID, which is my device ID, has not been registered. And the device ID check failed. And so the data, instead of going into the database that we created when we ran the database, actually the data was simply dropped. So what we need to do here is while WebStream keeps indexing the blockchain, we're going to register our device. And so basically that is the connection between the actual IoT device that Professor was mentioning also earlier, and that is then gets connected to WebStream, and WebStream knows what to do with it. So now we are going to CD into blockchain again. And I'm gonna run some hard hat scripts. So we did this, we did the walk. We now need to do authorization and the device binding. So we're going to run some tasks. Now, these tasks are in the blockchain folder in the hard.config file. And if you remember, I was saying, you know, we're going to leave this for later. And basically, so with the hard hat, you can basically create these tasks so that then I can call them from the terminal, and then hard hat knows what to do, right? And so the first thing that we're going to be looking at is this task that basically is register device. So register device is going to take the device ID, the device registry contract, and is going to then register this device with the logic that we saw in the contracts at the beginning with that mapping that we looked at earlier. So let's go ahead and do that. To do that, I need to run npx hard hat and then register device. And now you can see network testnet. It's what we had configured in the the other one, this one here, sorry. No, where was it? The other file that we looked at earlier that at the moment somehow I cannot find, but yeah, here in the hard.config actually, right at the end of it. So testnet is here. We need to basically add the device registry contract, the new one. And we just need to get the address from here. So device registry contract is here. And here, we just paste it. And the device ID is the same. So you see this 047D01, that's the same device ID that we talked about earlier. So we can basically just run this. And now it's registering the device. And hopefully everything works fine. Cool. And now we have some logs. This is basically, we have a transaction hash. That's the transaction hash for this transaction that just happened in the blockchain, which is basically what we were talking about earlier. So we made a change in the state of the blockchain. So we needed the test tokens to pay basically for it. This is what happened. Now, the next thing that we're going to be doing is to actually bind the device, this device, to my personal wallet address. I mean, the wallet address that I'm using for this demonstration. So, what I'm going to do is then look at the tasks. And we have this other task here, that's the bind device task, right? And so bind device takes the device ID, the owner address, and the contract address. So let's go ahead and do that. Again, I can just do npx hard hat, and then it's bind device. Again, we're on testnet. We just need to update the contract address. And so this is the bind device. So we just go here, we'll look at the output, we look at the device binding contract, we copy this, we open, and we paste it here. And now I would like to point out, so device ID stays the same, that's what we have, and the owner address is the address that's associated with my wallet, which is basically this 0x169 ending with D11. And so we just make sure. So 169 ending with D11, right? So at this point, we're good to go. And so now we're binding the device. You got it. And so after this is completed, I want to do some extra strenuous activity, and I want to show you that actually at this point, at this time, is not being rejected. So if we walk, really, walking up the hill. Okay, do a little bit more walking so we get a little bit more money, getting greedy. And this is basically the steps that we are going to then see in our wallet under the form of tokens. Cool. So now you can see here that this is the message that Simone was showing you in our first lecture, right? So we are showing the steps, the timestamp, the signature, and then the device ID, and then a couple of other information such as the cryptography, the curve that we're using, and the hashing method. Yes.
Earlier, we saw a message that the device was not registered and the test data was dropped. So was that from the web stream layer or was that from the software?
Yeah, that was from the web stream layer. So at that point, what happened is basically that we did send the message because the MQTT broker was working when we used the Docker. But then what happened is that WebStream did not recognize this device as a registered device in our own system here. Yes, exactly. Yes, exactly. So basically, once we send something, we send some some data, some steps or whatnot, then WebStream is going to go and check the blockchain and check that if this device is actually in that mapping. So it's going to call the mapping for the device ID that was associated with this device. And if he finds it, good. If he doesn't find it, then it's just going to, I mean, good meaning like it's going to put it in the database. If it doesn't find it, then it's just going to drop the data.
The team is going to do it all right.
Yes.
No contact.
No, it's going to I mean, it needs to look at the contract in order to look at that mapping, right?
So then that thing does not hold the device ID. Like,
The data, the web stream source is sort of like in a database with basically the device IDs and the steps and all that. But then it needs to check the mapping that we put in the blockchain in order to see if that device ID is actually registered in our application. Because if it's not registered, then it's just not gonna register the data.
so device also does this check with the blockchain every time activity.
Yes, and this mapping here is stored in the basically in the registry contract that we looked at earlier. And Simone is suggesting that WebStream is also indexing this registry contract. So when then, you know, and then is able to basically then make the connection. So at this point, okay, so this is keep indexing here. We did some steps. All we need to do is then claim the activity request and then claim the rewards. So what we're going to be doing is then run a couple of other commands that we can find here as well. And those are the claim activity request. That's basically going to take the device ID that we have and the walk to earn contract address. So it's going to call it for this device ID and do the claim. And then the claim rewards at the end when we will actually then ask to have these tokens then assigned to our wallet address. So let's go ahead and do the claim activity request. So we're going to again call MPX hard hat, and now we're calling the claim activity request. Device ID stays the same, network testnet, contract address we need to update. And contract address, we get it from here. We need the walk to earn. Okay, cool. And so we need the walk to earn. Just want to make sure. So claim activity request, device ID, contract address is the walk to earn contract address. Cool. All right. So we can go ahead and fire this. Okay, invalid param. Okay, no problem. Claim activity request, device ID. I'm missing the keyword there. And the keyword is, we can look at it from that. It's contract address. And let's see and make sure that the contract address is the same, the correct one. Contract address, so walk to earn. Walk to earn, it's the D3B7. D3B7. Okay, let's see if this works. Okay, so now it's requesting the walk-in activity. So this is calling that claim activity request function in the smart contracts that we looked at the beginning of the of this lecture. And so that happened. And now we're basically splitting the logic because we don't want to just make a claim and then WebStream just automatically send us the rewards in tokens. So we're basically splitting the logic in two. So we make a claim, the claim goes through, we do have it. Now we need to manually claim the rewards. So again, we're going to be, I'll just clear this so we have a little bit more room. We need to call the other task, which is claim rewards. So we do MPX hard hat claim rewards. And now claim rewards takes the owner address, which is my wallet address, stays the same. And the contract address, we just need to update. So if we look at here, the claim rewards, it's taking the walk to earn contract address. So the walk to earn contract address, we get it from here. Copy and go here. And we substitute it. Cool. Now we fire it up. And now it's claiming the rewards for my wallet address that's ending in 0D11, which we find in MetaMask here. It's 0D11. And so let's maybe look at them in parallel here. And we can see, I mean, it's pretty small. Maybe you guys have it bigger, but we have the 51 step tokens. So this transaction went, and this here, we got 51 step tokens. And so then, you know, if this was a real token, then, you know, you could exchange it for other tokens, like Professor, you were mentioning last time, right? It could actually have a real value, but it's like a whole different tokenomics session. And here, for example, we can actually look at the web stream logs when we made the claim. So if we just go up here, we can see the logs here. So the request ID was 0 from time 0 to time. So as I was saying earlier, you know, it starts at time 0 to the timestamp that's current when the request was made. And then we have the total steps, 51. And then I called the claim activity. And that's why I got the 51 steps here on MetaMask. And then obviously, there, you know, we could look at, for example, the transaction hash for this transaction here, and we could see, for example, a little bit more information about it. But basically, yeah, that is pretty much putting everything together. So I think, yeah, we earned you know, walking or whatever, moving the little board, and I just wanted to thank you guys for having the opportunity to do, you know, 2 of these you know, remotely, and at least to have 1 in person. So we got to meet you again, got to see the professor again. And yeah, I'm happy to answer. I'm sure Simone is as well. If you want to ask any other questions, we have about maybe 5 or so minutes, 7 minutes to spare. I know it's a lot of information. I was trying to like pack as much as possible into an hour and a half, but if you guys want and you go through the developers portal, it's much slower pace, obviously. So for example, you know, if you look at part 3 and now the web stream is all configured, it's much slower pace, and then you can actually look at things in a little bit more detail. And yeah, Simone was pointing out that part 3 is basically our lesson 2 when we set up web stream, and today we basically did part 2, where we actually look at the blockchain contracts. Just, you know, to make sure. So we did them a little bit in a different order, but the information is all there. And maybe try to follow the 1, 2, 3 that you find in the developer portal. But yeah, thank you. Thanks. It was a pleasure being here.
So you have a database?
Yes, basically this would be connected to a database. So it's indexing the blockchain and then is connecting to reporting those values into the database. I could actually try to open the database like Simone is suggesting. That's a very good point, actually. And so let me see here. So it's this 160. So 167.
A bit there.
And we can actually look at it. So I was in, I think, data. The layer DB.
Data layer DB again, and
DB, and then device data. Yes, so like exactly. So like Simone is pointing out, So we have this database here. That's where the web stream is recording all this data. And so we have the device table here, which is where the device that's registered is stored, which is only me, because that's all we did today. I mean, I just fired and registered the device. And then in the device data, we can actually see basically what happened. So we have the device ID. I mean, it's basically the same device, the steps, timestamp, the signature, and when it was created and updated. And so this would make it then much easier for you to, for example, if you're then building your own decentralized application on this data, then you can easily query this database and then do whatever sort of querying you need for your own type of application. Yeah, so Simone is also suggesting, for example, we're going to have this one here today on YouTube as well. And so maybe go through lesson number 2 and then lesson number 3 and try to follow along if you want and see if...
Students, if they want to get some hands-on experience. So hardware-wise, we need this one?
So hardware-wise, we basically use this board here, which is the Arduino Nano 33 IoT. And it's, it's a good board. It has the secure element. So we were able to then do the secure boot with a private public key pair. And yeah, you can just order. I mean, honestly, it's on huge backlog, both from the Arduino website and from, I think Amazon has them, but it's like a lot more expensive. Like I saw it on Amazon at like twice the value of what it should be on the Arduino website. On Amazon, I think it was in the $40-something range. But normally from the Arduino website, it's like $20 or something. Yeah, and then there are a lot of tutorials. There is a huge community. So yeah, it would be a good board to start with. And we also do have other tutorials, for example, that use this board in the developer portal. So for example, when we look at, we did the smart lock series, where to create a smart lock and control it remotely through blockchain, and that's the same board. And we also, this is the one that we sort of mentioned in lesson 1, because this has the link to the secure boot firmware to basically send verifiable data with Arduino Nano 33 IoT.
Secure element.
With a secure element. And yeah, so it could be a good start if you can get your hands on it. Do you guys want to add anything else? Do you have any other questions? Cool. Also, just feel free to reach out if you're trying this and something is not working, or need more clarification. Feel free to send us a message, and I'm happy to answer. Simone is happy to answer. Yeah, you can get in touch. Actually, I should have my email here on the slides, but yeah, my email is Giuseppe, just like my name, @IoTeX.io. Super simple, in case you want to reach out. And Simone is the same, Simone @IoTeX.io. Or join the, yeah, good point. Or just join the Discord channel, where we do have, a session for developers. We have a chat for developers. We do the events every week, where we do office hours where, developers can come with their own questions, and we try to help them as much as we can. We do the live streams, so plenty of opportunity to get in touch with us. Yeah, Simone was mentioning that Discord there. Okay, 1 minute to spare. Thank you, guys.
Okay,
Yeah,
thank you.
have a good day. Thanks.